Hi there. So in this particular video, I'll be providing you with a preview of exponential graphs. We'll be looking at two specific examples. Any exponential function or a function is considered to be exponential when your variable is in the exponent. So we're going to be looking at two different types. Here in example 1, we'll look at where your base is a whole number, and in example 2, we'll be looking at where your base is a fraction and compare the two. So in order to kind of be able to compare those two, we first need to crank out a graph of both of these functions. So in order to graph this function, we're going to look at it using a table. So we're looking at the function y equals 3 to the x, and I just utilized x values from -3 to +3. I feel like that'll give us a fairly good representation of this graph. So here at the top, you can notice here that my first x value is -3, and I've already shown a little bit of work here. So I've got 3 raised to the -3. We talked about in the previous section that you can't leave exponents negative in order to evaluate negative exponents. If it's negative up top, you bring it to the bottom, and then it becomes a positive exponent. So that's exactly what I've done here. So this becomes 1/3 cubed, and then we know 3 cubed is 1/27. So we've just created a y value of 1/27. Or an ordered pair that when we plugged in an x value of -3, we got out a y value of 27. And that'll be a point that we plot here in a few moments. Then the next one, I will have 3 raised to the -2. Can't leave that negative exponent, so since it's negative up top, I'm going to bring it down to the bottom, and it will become positive. And then we know 3 squared is 9. So now I've just created the point. I plugged in -2 for x, and I got a y value of 1/9. The next one, 3 raised to the -1, so that will be 1/3 to the +1, or 1/3. So -1 1/3. The next one, 3 raised to the 0. We spoke about that before. Anything raised to the 0 power is equal to 1. So 0, 1 will be a point on our graph. The next one, 3 to the first power, so that's just 3. 1, 3. 3 squared, we know is 9. So 2, 9. 3 cubed, 27. So 3, 27. So now let's go to graph these. So I have plot the point -3, 1/27, and I don't know if you're like me, I don't know what 1 divided by 27 is off the top of my head, so I just go to my calculator and type in 1 divided by 27, and I get 0.04. So it is a very small number. So -3.04, so just barely above, the x-axis. And then the next one, 1/9. So 1 divided by 9 is 0.11. So -2.11. So just barely above that last point. And then on 1/3 we know is 0.333. So just barely above, again, that last point. Now the next one, we know this one. So 0, 1. And the next one, 1, 3. 2, 9. And then the next one is 327. That's going to come way off my graph up here. I'm not even going to be able to really do it justice. So I'm just going to come way up there. And then I'm going to connect these points here best I can. Sort of freehand. Sometimes it just won't do quite what you want it to. There we go. And that's our graph, and this extends in this direction to the left as well. From that graph, you can see the idea of what's being said here in this first definition. Since your y values increase as your x values increase in this example, this is what we refer to as exponential growth. Another way to think about this is you read this graph from left to right, this graph is increasing, right? So as I read this graph from left to right, my graph is increasing. So that is exponential growth. Fact just below that, in the exponential function y equals 3 to the x, the y values can never equal or be less than 0. You're never going to be able to raise 3 to a power and get 0, okay? So for that reason, since your y values can never equal 0 in this function, there is a horizontal asymptote at the line y equals 0. And you may recall the line y equals 0 is just the x-axis here, okay? So this graph is hugging the x-axis, okay? And it will not cross it. By looking at the graph above, they want us to list the domain of y equals 3 to the x. So remember, domain are reading your x values from left to right. Range are reading your y values from bottom to top. So if I'm looking at this graph up here, this graph is going to the left forever, and it's going up and to the right forever. So hopefully you would agree then that my domain must be negative infinity to positive infinity. Range, on the other hand, the smallest y value, this graph is hugging that x-axis, but it's not going to cross it or touch it. So the smallest y value then would be 0, and then it goes up forever, so that would be 0 to infinity. You won't be able to put a bracket on that 0 because there's an asymptote there, so it's just a parenthesis from 0 to infinity. It gets really, really close to 0, but it never actually equals 0. So it will get like 0.00001. Okay, let's flip it over and let's contrast this to the exponential function y equals 1/3. Let me see if I can move this down just a little bit. It looks like it got up, about moved up. There we go. Y equals 1/3 raised to the x power. So another exponential function, just a base being here a fraction. So you'll notice in the first example, I'm still looking at the x values from -3 to +3. You'll notice that I have here at the top already done 1/3 raised to the -3rd power, and so remember that means that the top and the bottom are raised to the -3rd power. If it's a negative exponent up top, you bring it to the bottom and it becomes positive. If it's negative exponent on the bottom, you bring it to the top and it becomes positive. And then we know 3 cubed is 27. So here we find that when we plug in -3, we get a positive 27. Then I'll have the next one, I'll have 1/3 raised to the -2. So that's 1 to the -2 over 3 to the -2. Got to move these exponents, make them positive, so I have 3 squared up top, 1 squared on the bottom, and then we know 3 squared is 9. So plug in -2, 9. That will be the next point on our graph. And the next one, 1/3 raised to the -1. So top and bottom are being raised to the -1st power. So then that would be 3 to the 1st over 1 to the 1st, which is just 3. So -1, 3. The next one, 1/3 raised to the 0 power. Anything raised to the 0 power is 1. So 0, 1. The next one, 1/3 raised to the 1st power. So both of these items are being raised to the 1st power. So 1 to the 1st and 3 to the 1st. So 1/3. The next one, 1/3 being squared. So 1 gets squared and a 3 gets squared. These are positive exponents, so I don't need to move anything. 1 squared is 1, 3 squared is 9. So 2, 1/9. And then lastly, 1/3 raised to the 3rd power. That's the same as 1 cubed over 3 cubed. 1 cubed is 1, 3 cubed is 27. So I plugged in 3, got a y value of 1 over 27. Now let's plot -3, 27. So again, this is way off the chart up here. I'm just going to guesstimate. I'd have to go double what I have right here, so I wouldn't be able to even do this justice. -2, +9. Okay, you can start there. -1, 3. 0, 1. 1, 1/3. And then we start going, we know that 1/9 was 0.11 before, and then the 3, 1/27 is 1/27, so that 0.04. Okay, so here you're seeing, all right, here's my graph coming down, looking very similar from the previous example. You'll see that definition just below. Since the y values here are decreasing as your x values increase, this is what we refer to as exponential decay. Your graph is decreasing from left to right. Think about it as you read this graph. Follow this graph from left to right, it is going down, 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 right? So that's exponential decay. The question I have below there, is there an asymptote? If so, where is it? And hopefully you agree, yes there is. Basically it's the exact same one that you had before. There's a horizontal asymptote, and it's the line y equals 0. Okay. It's also asking us for here the domain and range of this graph. So hopefully you agree that this graph is going to the right forever. And then here on the left-hand side, it's going up and to the left forever. So domain would also be negative to positive infinity. The range, looking at your y values again, very similar, right? Smallest y value down here is 0, because remember this graph is hugging that x-axis, but it won't actually ever cross it since you got a horizontal asymptote here. So it's going 0 and then going up forever, so 0 to infinity. So, question just down here below then is, do you notice a correlation between the domain and range for these examples? And hopefully if you flip back and look now, they are the exact same. They are the same, that all of your exponential functions that are of the form y equals a to the x will have this same domain and range, okay? Question just below that, do you notice the difference between the bases in example 1 and example 2? And that's what was trying to point out to you at the top. So your first one in example 1, your base was y equals 3 to the x, so your base was 3. In example 2, y equals 1/3 to the x, your base was 1/3. If you recognize the difference here, that's the key to determining whether you have exponential growth or exponential decay. And if you'll flip back and look on that first one, your base was a whole number and you had exponential growth or decay. Hopefully you agree that that was growth. And here on this previous page, just look above here, our base was a fraction, and so that represented exponential decay. And that will always be the case. So then I would ask you now to look at examples 5 through 10 and check yourself with the solution key to determine if these examples below here would be exponential growth or decay, and you wouldn't even have to graph it because now you know what constitutes from the given function whether you would have growth or decay, okay, whether it's a whole number or whether it's a fraction. All right, let me know if you need anything. Thanks a lot. Bye.